Welcome to Programming Rainbow. In this video, we will continue on the beginner's guide to SDL3 in the C language. So if you'd like to follow along with this video, you can go to github.com, Programming Rainbow, and this will be called the beginner's guide to SDL3 in the C language. You can clone this repository, move inside the directory. There is some instructions if you're on Arch, by the way, and you can open it up with whatever editor you would like. You don't need anything fancy or special. It can just be plain text if you want, doesn't matter. And this is what it looks like. I just want to show the final project, what we're building real quick. I am going to mute the music, but we will still have the sound effects playing. So I'll be talking over the sound effects. Okay. And I'm just building it with GCC, although there is a makefile right here if you want to use that. But I just want to show for anybody who's a beginner, exactly the most basic thing that you need to do. Okay. So this is the final project. We have an image that we loaded as a background. We have a true type font that is also bubble font bouncing around the screen, but colliding with the walls and then saying SDL. We have this sprite that I can control with my keyboard. And it is also an image that's loaded, but it has a bubble around it as well. And the background is see-through, so I can press spacebar and get a random color for the render, and it says C when I do that. We also have the C icon up here loaded as the window icon and a title. Okay, so this is kind of everything that you'd need to get started in making your own kind of game. You can move things, collision, sound effects, music, so on and so forth. Okay, so what I want to do now is kind of make a bubble around the player. So let's bring up the player. Okay, so I want to make a bubble around this. Well, this actually turned out to be harder than I thought it was going to be. So the strategy that I'm going with here, and there could be a way better way to do this, but the strategy I'm going to go with here is I'm going to duplicate this surface to another surface, and then I'm going to set every single pixel. I'm going to look at every pixel in the surface, and if it's not transparent, I'm going to set it to a specific color. So it's either going to be transparent or it's going to be one color. And I'm going to loop over every pixel to do that. Okay. And then I'm going to take that one color surface and stamp it around in a circle. Okay. And I'm actually going to use that method and tie it in with what we were already doing here so that I don't have duplicate code. So we're going to change the way that we've done this as well. So to make it more generic. So now we'll be able to make any bubble text we want, and we'll be able to load any surface we want and also make that have a bubble around it as well if we want. So this, like I said, we're like looking at the pixels themselves in the surface. So this gets a little bit more interesting, I guess. So we have this surface, and we're going to be dealing with a lot of different things here. We have the width and the height, but we also have this pixel format, which we're going to be dealing with. And we have the pixels themselves. And there is another one. It's the palette. It's not, we don't see it directly here, but anyway. So that you get the idea that basically this is allocated on the heap, and it's just a bunch of pixels, but you have to know what format it is and everything else. So when we're going to duplicate a surface. So we have basically two surfaces, the original one and one we're going to manipulate the pixels on. And then we are going to lock, to give us access to manipulate the surface, we need to lock the surface. Okay. So this is just to set a surface up for direct access, accessing the pixels. We're going to do this to lock the surface. Then we are going to get the pixel format details. So we've already done this in the other video. I don't know if we got the details, but we set something as it. This one, since I don't know what surface I'm dealing with, I'm going to get the details of the original surface that I'm manipulating, because it could be in different formats. It could be ARGB or RGBA, and I don't know what it is. So I'm going to find that out. So in the last video, we set it directly as ARGB, but this is actually getting that information for us. So we're going to get that information that we need. I'm also going to use this to make sure that it is in fact a 32-bit wide pixel, because if it's not, we're just going to bail out, just for a little bit of safety. This is the pixel format details, and one of the things is the bits per pixel. So we're going to check to see if that's 32-bit. And we're going to get the surface palette, and on a 32-bit this is actually going to return null. So it's fine if it does return null. I'm just going to get it anyway. And then we're actually going to get the pixel. And what I'm interested in is the alpha. If the pixel is transparent, I don't care. But if the pixel isn't transparent, I actually want to set the RGB to a specific value that I'm going to choose. And I do that with SDL map RGB. And you see that we need the format and we need the palette. And then we have the RGB and alpha. So I'm basically making a monochrome surface, but I get to choose the color it is. And then when we're all done with that, we're going to lock the surface again. So yeah, this is a little bit of a rabbit hole, but I did it the other day when I should have been streaming. And so I'm going to show everybody else at least how to do this. I don't know if this is the best way in the world, but this is one way to do it. So I'm going to be making a new function, and this is going to tie in with the bubble stuff in a second, but I'm going to leave these functions alone in the bubble. I'm going to make a new one called bubble surface. We're going to deal with before I even think about the bubble stuff, I just need a surface that's a solid color created from another surface. So I have a helper function here called solid color surface. And we'll start with that one. So this is just going to be a helper function. It's not going to be seen outside of here. So it's going to return an SDL surface. And this is going to be everything I just explained, basically looking at all the pixels of a surface given. And if it's not see-through, it's going to be set to a solid color. And we're going to receive an SDL surface. I've just called it surface. Yeah. I'm going to call it source surface because it may get confusing. Source surf. And then we need an SDL color. I'll just call it color. So we have a surface. The very first thing I'm going to do is to see if we really did get a surface. If we got like a null pointer, that's a problem. So I'm going to say if source surf f print f, and we can say error surface is null or something like that. Because if it's null, we can't really do anything further. So we're just going to return null. Because we are returning a surface from this, so we'll return null. Okay, so if we do get a surface, we need to duplicate this surface. Because I don't want to edit the surface that I've passed in, because you may need that for something else. I'm not editing that surface. I'm going to create a new surface. I'm going to do the edits on that new surface and return that new surface back. So to do that, we're going to use a duplicate. Where is it here? This SDL duplicate surface, this is making a duplicate of a surface. Not just two pointers pointed to the same surface, but an actual duplicate of the surface. So here's the SDL surface, and I'm going to call this color surf because we're making a specific color surface. SDL duplicate surface, and it just needs a pointer to a surface. And that will be our source surf. Yeah. Okay, we want to know if this is a null as well. So color surface, And let's say error copying surface. Now we can also get the SDL error. And I think that's right. Now, if this does fail, we don't need to free this other surface because this is a surface that's external. We're passing in a surface, so we don't ever need to free that surface that we passed in. The source surface is not, we're not editing it. So I don't want to edit this from inside. So I'm not freeing it or anything in here. I'm just going to pass back null, just pass back null here. And now we are going to lock this surface. So this is something that can fail. So I'm going to check it, and it's SDL lock surface, and we're locking the color surface. And if this one does fail, we do need to free the color surface. So I'll say error locking surface. And we do need to free the surface before we return. And it's going to be called color surf. Okay, so now we have a duplicate of the surface and we've locked it so we can play with the pixels. Now I need the width and the height of the surface. So I'm just going to create two variables to hold them. And it is an int. That's the type of the width and the height in the surface still. What am I doing? Surf h. Okay, so that gives me the width and height that I'm using. So the first thing I want to do, because I want to make sure that I have to cast these pixels to, these pixels are, let's see if we can look at them. So these are void pointer pixels. I have to cast them. And I'm going to cast them to an unsigned 32-bit. But I need to make sure that they are in fact 32-bit because they could be of a different, they could be 8-bit or something like that. So before I cast them, so I can index into all these pixels, I need to make sure that I am dealing with 32 bits. So I'm going to use the get pixel format details, get pixel format details. And here's the details. And I have bits per pixel. So I can make sure that it is 32 bits. Okay, from this. I also need to use this for something else as well. But the very first thing I do before I go any further is to just make sure I am dealing with 32-bit formatted pixels. So I'm going to do this SDL get pixel details. And this returns a pointer. Let's see, does it talk about this here? Yeah, see this right here? So what we need to do is put the format in here, and we can get that from the surface. Surface format is a member. And it's going to return, and I'm going to call this format details is what I'm going to call it. Okay, so I'm just going to copy this whole thing right here. So I'm going to call it format details. And right here, this is actually the format of the surface. Color surf format. This is different in SDL2. SDL3 is different now. So I have this. I do need to make sure that this is not null. So we're going to see if this format details is not null, or if it is null, something's gone wrong. So I'm checking the is null right now. And I do need to do this. I need to free the surface again. So I'm just going to take this right here and just make a message, because I do need to free the color surface before I return null. So let's say error ting for format details. Yeah, and then I'll get the error from SDL. So we should have these format details. I know this is getting into the, a little bit complicated, but we can now check to see if this is equal to 32. So we can say if format details bits per pixel, and I'll say is not equal to 32. So if it's not equal to 32, something's gone wrong. And kind of like this again, except we don't need the SDL get error from it. We don't need this bit right here. So our message is going to be, we can't go any further. This needs to be a 32-bit because I need to cast this thing to a UN32. So I can say surface is not 32 bits. Error, sir, not error, not a 32-bit surface. Okay, error, it's not a 32-bit surface, and we need to clean up this surface, and we can continue on now. So now that we do know that we do have the format details, and we do know that this is a 32-bit surface, we can cast the array of pixels now to to a unit, because it's a void pointer. We need to cast it. I'm going to cast it to a uint32. That's why we needed to make sure it was 32-bit. So I'm going to call this pixels equals, and this is going to be color surf and pixels. Okay. And we can see if this is also, we could check if this is null as well, but it can't be null because we've already checked this up here to make sure the surface is not null. So these are the pixels in the surface. If the surface, like the other thing we have here is the palette. Now the palette, I believe on 32-bit, let's see if I have it up here. Pixel format details, get the palette. So when we're dealing with this get RGBA, we need the format details right there, and we need the palette. Okay, but I'm pretty sure on 32-bit the palette is null. Get surface palette returns a pointer to the palette by the surface, or null if there's no palette used. And I believe 32-bit is already, it's null anyway, so mine is going to be null, but I don't know if that's in every case, so I'm just going to use the function to get it. So I'm going to use this right here. I'm just going to call it palette. So this is going to return a pointer to a palette, but it could be null, and if it is null, that's okay. It's not a failure. That null is a valid value for this. So it's not null on failure, it's just null on there isn't a palette being used. So this one will be, I'll call it palette. And the surface is the color surf. Okay, and again, we don't need to check anything on this because if this is null, that is fine. That's an okay value. Okay, we're getting closer. We got all the information we need now. So now we can start checking the pixels. So we're just going to use two for loops for the width and the height, and we're just going to go through all the pixels now. Okay, so then I'll start making sense. Int, and I'll say y to the height, sure. Y equals 0. I don't know why I'm doing y first. It doesn't really matter. So y is less than height. And then we'll do an int x. Okay, so there's our for loop. So we can loop through all the pixels because we have our width and our height up here based on the width of the image and the height. So this should be able to index through all the pixels. So we're going to get one of the pixels out. So we're going to cast that one pixel. Or not cast it, sorry. It's already been cast. It's a UN32, and we'll call it pixel. And it's from the pixels array that we got right here. That is this right there. We could have just plopped this in here as well in place, but so this is not actually like a 2D array, so we have to do the math on this. So this is going to be y times width, or width times y, either way, and then plus x. And that's because it's not a 2-dimensional array like this, it's a 1-dimensional array. So that's how you do the math on that. You take the width. Let's say it's a 10 by 10 picture. If you wanted the very first pixel, the very first pixel is going to be 0, 0 on the x and the y. And then if we move over 1 on the x, well, the y is still 0. So if we use the formula width, which is 10, times y, which is 0, that's going to be 0. And then plus x. If we moved over 1 to the right, now our x is 1 position. So if we get all the way over to the 9th position, the final position on the x-axis, y is 0 times 10 is still 0 plus 9, we're on the 9th position. So then when we go to the next position down, which is going to be y is now 1 and x is 0, right? That's actually the 10th position. And the way that we get that is we take y, which is going to be 1 now, because we've moved down 1, times 10, which is 10, plus x, which is 0, and we get the 10th position. So hopefully that math makes sense. So it's width times y plus x, and that's how we get a pixel. Now I need to hold on to these RGBA. They're UN.8s. So I'm just going to do RGBA. So we can pass them in. And then it's SDL. Now we're using this function, this SDL get. So this is get RGBA. So to use this one, we need a pixel. We need a format that's from the surface that we've already gotten. We need a palette that's from the surface that we already got. Then we need to send in the address to this RGBA alpha. Okay. SDL. I don't think there's a get a RGB. No. Okay, so we need the pixel, which is just called pixel. And we need the format detail, or the format details, which I called format details. We need the palette, which I called palette. Oops. And then we need the R, G, B, A. Yeah. So that's going to populate our RGBA. Now we need to just know, is the alpha, if the alpha is 0, it's transparent. Okay. If it's anything other than 0, it's not completely transparent. So I'm going to say if A is bigger than 0, if it's bigger than 0, there is some type of color happening on that pixel. If it's 0, it's transparent completely. So if it is, we're going to set this pixel. So pixel, we're going to use this map RGB, which is just like the get one, map RGB, but we are not sending in the pixel this time. We're going to get a pixel back. So this is going to be the format details again, the palette details, and then colors. Yeah. So it's SDL map RGBA, and we need the format details, the palette, and now we want to replace the color with whatever color we've passed in. Sorry, these need to be the addresses. I missed that because these are being assigned in this function. So we've created this RGB here, and we're passing them in. This function is populating these values. Okay, right up here we have this color, this SDL color. So I want to change. I don't care what color was in here before. If the alpha is set at all, I'm going to overwrite that to my own color. Yeah. So I'm going to use color.r, color.g, color.b, and the alpha is not really important. We can just use alpha. We can just preserve the alpha. That's what I'm saying. Okay, so this is setting the value of a pixel, but it's not putting it. It's just setting the value of this pixel externally. It's not the pixel that is in the array. So we need to put that into the array now, or put that value or whatever. This is basically this is a uint32 is what this is. So we're going to assign this uint32 value back into the array. So pixels, and we need to index it the exact same as it was before. Right here, I'm just going to yank this. We're going to set that to the pixel. Okay. So this is going to basically go through the entire thing, and it's going to set the color that we want if the alpha is not set. Right? If the alpha is transparent, we don't care. It's going to continue to be transparent. Okay. So the last thing that we need to do, that we've edited all this pixel stuff, is we need to unlock the surface, because we've locked the surface so that we can edit it. Now we need to unlock the surface. And that's just, it's just void, and it's just doing what it says. So SDL unlock surface, and this is a color surf. And then finally, we can return this surface, this color surface. That was a lot. Sorry about that. That is a whole lot. I kind of want to show you something now. So what we're going to do is we're going to load. Oh, we're going to load it as load the image as a surface, not a texture, and we're going to send it to this function, and then we're going to convert that. So I'm going to kind of grab this right here because I'm going to use it in the player, even the width and the height. Although we could use the other one, it doesn't really matter. We can use the existing one. We don't have to use this simpler width and height, but we do need to convert. So I'm going to yank this right here because we loaded the player directly as a texture, not a surface, right here. So I'm going to change that. Let me just paste in what I'm holding on to real quick. I'm just going to ignore all those errors. I'm going to duplicate this and comment it out. So I'm going to just create a surface locally here. And I'm not going to use image load texture. I'm just going to use image load. That means we don't need the render. And this is surf, error loading surface. Okay, so we're loading that same image, but as a surface, not a texture. And then we are going to send it into that function. And that is bubble. Sorry, I need to make that function available. This is just called solid color. So this is not going to be normally used outside of this module, but just for us to see something right now, I'm going to do it. So I'm going to put it in bubble H. I just want to, after we've done all that work, I want to see something. Okay, so right now we have access to this solid color surface. We can go into player and we can include the bubble. Bubble.h. And then we can use that. So I'm loading a surface here. It's going to give me back another surface, unfortunately. So that's because I didn't want to think about editing the surface inside of it. So that's fine. So I'm going to create another one. Color surf equals, and what is it? Solid color surf. We need a surface, which is just surf. And then we need a color, and I'm just going to create the color here. Or we could just use a color. We could use white. That's already defined, white color. Or we could use blue. Now, this can fail. If it fails, it gives us back a null pointer. So I need to check this. And I actually don't need to print a message because the message is already printed out inside of, it would fail inside. It would print out a message. I just need to return this. But this is color surf. And also, I don't need the surface anymore, this original surface anymore once I've done this. So what I'm going to do is before I even check it, I'm going to do SDL destroy surface and surf. Okay, so I'm not holding on to a surface longer than I need. So this surface is created. I'm sending that surface into this function. Before I even check it, I'm going to destroy it no matter what because I'm done with that surface. Now I have this surface here. This is player. And the render is the P render. And this is color surf. And I'm going to destroy color surf. Again, before I even go any further, once I've used it, I'm getting rid of it. Oh, and I set this to null, so I could do the same here. Surf is null. That's a good idea. And then we're checking if P is valid. And we don't need to free anything else because these things are already been freed. So now that's the same. I can still use the get width and height out of the texture. Everything's the same. Okay, so hopefully if I've done this right, what we're going to get is we're going to get the SDL logo, but it's just going to be all blue. Hopefully. Yeah, there we go. We got a blue logo. Okay. Now I'm going to generalize the text bubble making thing so I can just make a bubble out of anything. So yeah, I'm going to start generalizing I don't need this or this because I'm not going to use this color one externally. What I'm going to do is have a bubble one and a text one external. So I'm just going to leave this how it is right now. I'm going to go back in here to bubble. And basically right now I have this, where is it? Right here, this solid color surf. This is doing, before I was needing to make two surfaces. Well, I don't need to do that now. So I can kind of generalize this a little bit. But before I start tearing into this to generalize that, what I want is to just be able to make a bubble surface. I don't care what the surface is if a text surface, an image. I just want to generically make a bubble surface. So I'm going to kind of cannibalize some of the stuff out of here to make a more general function. And I'm going to have this return a surface as well. So we're not going to do anything new here. I'm just moving things around just to make it more general. So I'll call this bubble surface. And this is going to receive a surface, a radius, and an outer color. And I called it surface. I'm going to call it source surface for, readability and understanding. So int radius, and then an SDL. I'm going to call it outer color. This is going to be the highlight color, the outside color, the bubble color. Okay. So the first thing we need to do is make sure our surface is valid. So I think I've already done this up here. I'm just going to take this because this is exactly the same. Okay, now that we know that we have a valid surface, I want to get the width and the height of the surface times 2. We've kind of seen this here, this right here. Sorry, where's the one that I'm trying to cannibalize? Yeah, I'm just going to yank this and I'll just separate it out. Makes it a little bit more readable. So I'm going to create a int width and height. And I could just take this and then remember we need the radius times 2. So I'm going to take this right here and I'm going to take plus radius, because this is, do you remember we're making that target surface that needs to be larger so that we can stamp around in circles. So that's what we're doing. Nothing new is happening here. I'm just moving things around. So if we look down here, I actually did it in line. I got the width of the surface, which I'm calling, this is going to be source surface. Okay. But here I just called it surf. I got the width plus radius times 2. You see that? It's the same. So I'm going to do that. I can just use the format directly, right? From the other. Is it pixel format or format details? Let's see what this needs. It says pixel format. Okay. So I'm going to use the format of the source because I don't know what it's going to be. So I'm going to create a target surface just like this. I'm going to use SDL create surface. We already know this. I'm going to use the width and the height that we just calculated to make this easier to read. Width and height here. Okay. Now this pixel format, last time I hard coded it. This time I'm going to take it from whatever the source surface is. And this is a member. It didn't say format details. It said format. So hopefully I can get away with going source surf format. So it's going to make the target surface the same format as the source surface. So that will be good. Now we need to check the surface. We don't need to free anything or destroy anything. Nothing's been created. This is the first thing that's creating something, so we don't need to free anything. Creating new surface. So the next step is we're going to use this solid color surface instead to create our outer surface of the other color. We're going to make another surface. This will be called outer. And we're going to use the function we just made that does the whole solid color. Instead of creating a new, since we don't know if we're dealing with text or if we're dealing with the surface we loaded, we're just going to use that function that takes whatever surface and makes it into a solid color. So this solid color surface, and this needs a surface. And this is good that it's not destroying the original surface, so I can still use the source surface. It's not trying to edit it or anything. So I'm going to use the source surf, and the color is going to be the outer color. Sorry, outer color. Okay, so, and this is making a new surface, so we do need to check this. So I'm going to use this same setup right here. So this is the stamping one. This one is going to get stamped around onto the target one, and then the original source one is going to get center stamped. So the original one could be text, it could be colors, we don't know what it is. But this is making a solid color version. We're going to stamp it around a circle, and then we are going to center stamp this one, and it's all going to be done on the target surface. So the problem is here, if we fail on making this outer surface, we do need to clean up this target surface. Destroy surface, and this one is the target. So now we are set up. We have our target surface, we have our stamping one, and we have our center stamp one. Okay. So why don't we just kind of grab the algorithms out of here, right? So I'm going to take that algorithm, and I've changed the name slightly. So this one's center stamp, splits, destroy surface, return surface. I'm going to just grab all this and just, I'm going to need to change some things, but it's going to mostly be the same. Okay. So this one, this is the one that we are stamping onto the target. So this one is called color surf, I think. Outer surf, that's what I called it. So that's outer. And we don't need any of this stuff going on right here where we're creating a new font. We don't need that because we already have the center one. It's the source one. So we need to blit the source one, which is src onto the target. So this is all the same, yeah? Okay, so we are going to return the target. We do need to free the outer one. And this will be the width of the source. Now the other algorithm will have to change something too. So let's just uncomment it real quick so that if anybody's using this. This is the outer. Did I do the outer? Yeah. Okay. So that's basically, it's going to take any surface that I put into it. It's going to create a solid, I'm going to give it a color. It's going to create a solid version of that color and make it into a bubble surface. So I could send in a text surface or an image surface or anything. It's more generic now, yeah? So now we have this bubble create surface, the original one. This bubble create surface needs to do a lot less work now. So we still need a text for the original one. Here's our font. Here's our surface. I called it text surf. Okay, so we have our surface. And then basically after this, we don't need to do a lot of other things. We're going to send it into the bubble one, and we're going to call it bubble surf. So we have this surface. Yeah, that's right. Bubble surf equals, okay. So we can use this bubble surf, and we're going to send in the text surf. And we're going to send in the radius, which is already set to radius. And we can send in the outer color, which is already outer color. Yeah, that. And then we just need to make sure that this has not failed. So we bubble surf error. Oh, we don't need an error message on this one because the error would be inside of the function. But we do need to think about what we're cleaning up. So we have the text surface and the font. So I'm going to free the text surface up here. Actually, I don't need to put it inside here. I can put it up here because I'm not going to need this font again, or this surface or this font. Sorry, this right here, I don't need it in here at all. I only need it here one time. Now it's there. So once I go to run this function, I don't need the font again. I can free it, and I'll set it to null. Okay. And the same thing, I don't need this surface again, so I'm going to destroy it. So that is the text surf. And then text surf equals null. So I don't need to close a font here. Okay. So I don't, in my notes, I have it destroying the surfaces, but I don't since I've just destroyed them as I use them. Now I don't need any of this other stuff. This stuff is all taken care of for me now. Oops, I scrolled it and then it unselected it. I was just making sure I wasn't in a different function. Okay, so yeah, if we're here at the end, we can just return the bubble. So now we have this ability to create bubble text, but it just uses those two helper functions that we've done. And since we've taken this out, we can just access this externally now as well for any surface that we want. So I'm not going to do this solid color surf externally. I should probably move that. I'm going to do this one. Actually, it's above. I put it above. And I'm just going to move this right here. because it doesn't need to be seen externally. Okay, so the other one needs to be forward declared. Right there. Let's see, so I got two, I should have 4 functions in here. So you can kind of see everything is more generic now. The text should still work the way it did before, but now I'm not actually making a text to surface twice. I'm actually only doing it once. I'm taking that one and turning it into a solid color as a new, and turning it into a bubble. Let's link this back up. So text doesn't need to change, but player is going to need to change because this was just creating a solid surface. We'll call it bubble, and I'll call this bubble surface. I'm going to use did we put this in the main H, the radius? Yeah, bubble radius. I'm going to use that to give it the same. So let's see what we need a color and a radius. Yeah. So I'm going to use bubble radius and let's say white color because I'm using the blue color on the other one as the external. So it should load this surface, turn it into a bubble. I'm destroying the surface right away so it doesn't exist anymore. And then here I'm destroying, I don't like this. What's going on here? Bubble surf. Oh, this is the original surface. Okay. So I'm destroying the original surface right away. Now I'm destroying this bubble. And this should be bubble. This one is bubble. Okay, all the same now. Okay, so now I should have the proper image and with a highlight around it. There we go. It looks like I've messed something up here. Yeah, I'm not sure what I've done here, but this is working correctly. Huh. What have I done there? I didn't use the same color twice. No, that is the create bubble text. Create bubble text. I have an inner color and an outer color. Okay. The inner color should be white, and that should be the original. I'm using outer color here. Wait. Render. Yeah, this is the inner color. And then when I do this is the outer color. There we go. Okay. So now, yeah, I can take anything and I can set these bubble colors to whatever I want them to be. And I can change the size of them too. I don't have to use the 15. I could change it to something else. Let's go into player. So the radius, I could say it's 30, make it twice as big. And the color, I can just make a color right here. So this can be, let's see here. Sure. Okay. So I've made it bigger and I've made it like a purple pink color. Yeah. You can kind of see how that is just whatever you want it to be. Okay. So I'm going to set that back to what it was. Just using those. And you can kind of see now that you can just take any picture. I'm going to leave this right here, the original, if you just want to load a texture and you don't want to mess with any of this stuff. And you could just comment out all this surface stuff down here, all this all the way down. Okay. I'm going to use my other compiler to make sure I haven't made any mistakes. Okay. And okay, good. No memory leaks. Okay, let's just walk through what we've done here. We don't need main here. So I've basically made the whole bubble thing generic. We had all this stuff before making the bubble text, but the first thing we did was make a way to create a solid color. Where is it? Solid color. Here it is, right here. So we have to go through quite a steps, but basically we want to go through all the pixels in a surface. And if there is transparency, we want to set that pixel to a color of our choosing. So we're passing in a surface and a color. We are making sure the surface isn't null. And then we are going to duplicate that surface because we don't want to edit the original surface. We want to create a new surface that'll be our color surface. And we need to lock the surface so that we can edit get access to the pixels and edit the pixels in it. We're also going to get the width and the height of the surface. We're going to use that for indexing through the pixels. We need to get the pixel format. And this is for two reasons. One, we want to know that if we are 32-bit or if we're using 32-bit format. And the other one, we need to use it in the get RGBA and the map RGBA. So we need this very long, where is it? The SDL pixel format details. So this is a pointer and we have to use this function to get it. So we're checking to make sure this isn't a null pointer. And now hopefully we have these format details. And we're going to use those format details to see if we are in fact 32-bit. If we're not, we can't really do anything else with this because I'm casting it to a UN32, so I need it to be 32 bits. So if you're using a different format for your images, you're going to have to edit this code or make it more generic somehow. I'm not really sure, but I'm casting this to 32-bit ints, so I need this to be a 32-bit. So the pixels in the surface, I do need to cast them. So I have this array of 32-bit ints. And the palette could be something or null, but it's okay if it is null. But I'm using the function to get that as well. Now we're going to loop through with the width and the height. You know, through X and Y, we're doing a nested loop through each of the pixels. We're going to take one of the pixels and we need to do the math on it because it's not actually a 2D array, but to get one of our pixels out. And these are going to be the RGBA values. So we're going to use SDL RGBA, get RGBA, sorry. We're going to put in our pixel, which is going to be UN32, but we need to put in what format that is, what palette it is. And then we are passing in the address of RGB and A to populate those. We're going to just check the alpha. That's all we really care about. If alpha is anything other than 0, that means it's some color. And then we're going to set this pixel using the format and the palette. We're going to set it to the color that we wanted that we passed into the function. So we're going to use color R, color G, color B, but not for alpha. Alpha, we're just going to leave alpha alone. Let's see here. So that is going to make every pixel, this is returning, a UN32. So this UN32, we're setting that value back into this indexed value in the pixels array. So we're going through our entire array of pixels and we're setting everything that's not transparent to a solid color that we choose. And that's that. And then we need to unlock the surface. And then we're going to return that color surface. So we didn't affect the original one that we passed in. So you still have the original one, but now we've returned this new surface that is just a solid color. And to do any kind of bubble surface thing, we're going to send in a surface, a radius, and a color. We're going to make sure that surface is real. We're going to give us size on a bigger surface using a radius times 2 added to both the width and the height. We're going to make a new surface, we're going to use the format of our original surface. So the formats match. And we are going to make, we had some surface that we sent in, but we need that solid color stamping surface, right? So we're going to use that solid color surface function we just created above to pass in this surface, pass in a color, and it's going to return us a new surface with that solid color. So basically we have our original surface we're passing in, we have our target surface that's larger, and we have our bubble outer color surface, right? Now we can just use our algorithm, either one, to stamp it around in a circle, and then we'll take the original source surface and we'll center stamp it. It will destroy the outer one, we don't need it anymore, and then we just return the target surface. So that gives us a generic bubble, effect around any surface. So since we've taken all the algorithms out and put it into this generic one, now when we go to make bubble text, we can just lean on these other functions. We still need to create a font, so we're still sending in the same information. We want a string, a size, a radius, an inner color, and an outer color. We take the inner color, we make our font with the size, then we make our text surface with the string, with the font, and the inner color. Okay, so now that we have that, we can use our bubble surface and send in that text surface that we just created with a radius and the outer color, and that creates the bubbleized version of it. We're going to destroy the text surface that we don't need anymore. We have this bubble surface. We make sure that this is not null. If it is, we something failed and we return null. If not, we're returning the bubble surface. So now this works the same in text, although we had to fix an issue with it was inside the bubble thing with the colors being off. But we still call it from text the exact same way. Nothing has changed in here. Okay. But we can do it in player now, that if we load the player image as a surface, we can make the bubbleized version of it, convert it to a texture. We can get the width and height. We can also get the width and the height from the surface directly. The other way, I just left this one in. And we also are dealing with this whole key state. So we can move around and stuff. Okay. So I think that's everything. That was a whole lot of information. I know I kind of went down a rabbit hole with the whole editing pixels. I thought it was going to be simpler when I started on that journey, and it ended up being per pixel. So I hope you enjoyed that. I hope it was entertaining, and I'll see you in the next one. Bye.